All right, so this is the setup that we're going to be doing for the pH demo. And remember that pH stands for potential hydrogen. So we're going to be using the pH scale on a couple of solutions. Some of them are everyday, some of them are not as commonly ones that you'll encounter, but we're going to kind of test the pH out of each of these and compare them to what you predicted. I'm also going to ask you to be telling me the actual concentration of hydrogen ions in each one, and then I'm going to ask you to compare them to water. So we know that water is a pH 7, so you'll be comparing each of these pHs to a pH 7 and telling me how many times more basic or how many times more acidic they are. Now, okay, so for your page setup, I'm going to ask that you go ahead and let me take myself out of this because I won't be standing here anyways. So I'm going to ask that you go ahead and title your page. You can type this or write this. I have no issue with either. You want to title it with pH demo, and then you want to write your name and your date in the top upper right corner. And this is always a good habit. Okay. And in total, we're going to have 9 solutions, but for each solution, I want you to write solution number. So this will be solution number 1, and then leave a space for the name that you're going to fill in. And then I want 4 things for each solution. Now, the first one is before you even get ahead to actually figuring out the pH, you're going to make a prediction. On a scale of 0 to 14, you're going to predict for this solution, what pH do you think it is? Do you think it's acidic, basic, really strongly acidic, or really strongly basic? Remember, 0 is super, super acidic, 7 is neutral, and then 14 is super, super basic. So any numbers between 7 and 14 are basic, any numbers between 0 and 7 are acidic. Second off, we'll be calculating actual pH using these pH test strips inside the liquid. I'll actually explain the test strips in a second. After you get the actual pH, then you can do number 3, which is calculating the concentration of hydrogen ions. And this is the symbol that we use for concentration. It's these brackets, and you put whatever you want to find the concentration of inside of the bracket. So in this case, for pH, we're finding hydrogen ion concentration. So that means your setup for this one is going to be 1 times 10 to the negative. And then whatever the power is going to be is actually the pH that we just found. And then lastly, you're going to tell me for number 4, solution 1, you're going to tell me what it actually is. For example, if it's water, then water is blank times more acidic or basic than water. So water is supposed to be a pH of 7, right? And 7 is 1 times 7, right? So water is 1 times more basic than water or acidic than water. For another solution, for example, if it's something acidic like cranberry juice, we would say cranberry juice is, and say it was a 5. So cranberry juice is, when you move 5, you go 5 to 6, 6 to 7. So that means 10 times 10 equals 100. Cranberry juice is 100 times more acidic than water. And it's acidic instead of basic because you know that you went to the lower end. You went from 7 down to 5 in comparison. If it was a number bigger than 7, then you would use basic. Okay, so I'm going to have you set these up from solution 1 all the way to solution number 9. Okay, we're going to be doing 9 solutions. So go ahead and pause and set this up. Now, we're going to go ahead and explain what the pH strips are. So as you can see, they come in this little container, and it comes with a scale that tells you 1, 2, 3, 4, 5, 6 for the color comparison, and then pH 7, 8, 9, 10, 11, 12. So the pH strips don't actually go all the way to 0 and 14 because we just don't have an easy way to kind of demonstrate those in a lab setting yet. If you go into a more expensive lab, they have chemicals that can react and just tell you what the pH is. So the actual strips inside are just this kind of orangey yellow color, and they're not anything super, super special. They just originally kind of start out around the 4 or 5-ish color, but when you dip them into a liquid, then they might turn darker in a bluish tone or turn darker in a reddish tone to tell you what pH. So basically, after each time I dip this into a solution, then I'm going to compare it to the chart, and you're going to estimate approximately which number it matches best with. And again, these are all estimates. So if you're not exactly accurate, that's okay, but I just want you to be kind of aware of which side of the scale these kind of liquids land on. So I'm going to put the extras over here. So again, we have different solutions. I want you to pause and write down the name of the solution after each one that we go through, and then go on with your prediction. and then watch the demo for the actual pH. Okay, so the first solution that we're going to be doing is a typical breakfast solution that you consume, and that is orange juice. So take a pause and write down orange juice, and also predict what pH you think it's going to be from a scale of 1 to 12. Now, I'm going to take a test strip and actually dip it into the orange juice, and then I'll compare it with the pH table. So as you can see, I'm dipping it into the orange juice. And then we're going to compare the color here. So you're going to see if it matches with the number. So let me hold this for you so you can see. Does it match with pH 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12? Okay, so if you need to pause at any point, you can always pause to go look at it. So now, let's look at solution number 2. And we're going to, you can pause if you want to do your calculations in between, or you can pause, or sorry, wait at the end to do all the calculations, but we're just doing prediction and actual pH now. So solution number 2 is going to be milk. So this is whole milk. Make your prediction. So I'm going to dip this into the whole milk. And we're going to see. Now, if you notice, it's actually a little bit more yellow than the original strip color, which was kind of orange. So if you compare it to the pH, is it pH 1? Is it pH 2? Is it pH 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12? Okay, so that was solution 2. It was milk. Solution number 3 is going to be, let's do something else y'all encounter on a day-to-day basis. This is CocaCola. So this is CocaCola. Make your predictions. Let's go ahead and test it out on a test strip. Notice that it's fizzing when it comes in contact with any surface. Okay, so this is CocaCola. I want you to tell me, is it a pH of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12, based on this reddish hue? Again, remember, you can pause whenever you need to. So solution 3 was CocaCola. Solution 4 is going to be lime juice. Let's do lime juice. Let me actually move the journal real quick. So solution 4 is lime juice, and we're going to take a look at the pH of lime juice. So if I take it out here, is it a pH of 1? Is it a pH of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12? Again, this is the pH color. All right, solution 4, that was lime juice. Now we're gonna try solution number 5. Is gonna be something a little wonky. So I took Tums and I dissolved them in hot water. So this is Tums, right? Usually you eat them when your stomach is not feeling well because you have acid reflux. So thinking that this is something that combats acid, maybe make your predictions based off of that. Here's the pH strip. Dipping it in there. And we're gonna look. Is it a pH of 1? Is it a pH of 2? Is it a pH of 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. Again, this is the pH color. Is it? And that was solution 5. That was Tums, Tums. Solution 6, let's do something you definitely see every day, and that's water. Okay. Those of you thinking, this is kind of dumb, we already know the pH of water. Well, it always helps to test it out too. Okay, so we're gonna take a pH strip and put it in the water and see. What is the pH of water? Now, you can see the test strip did change color because the original color is a little orangey. Okay, and if you notice, some parts of it are a little bit different colored from the rest of it. Okay, so here we have, is it pH 1? Is it pH 2? Is it pH 3? Is it pH 4? Is it pH 5? Is it pH 6? Is it 7? Is it 8? Is it 9? Is it 10? Is it 11? Or is it 12? This pH strip color. What does it match? And these are also just best guesses. They're not going to be perfectly accurate, and that's okay. So the next solution, and that was water. That was number 6, and that was water. Number 7, we're going to try one that's leaking everywhere. Actually, we'll do the leaking one last. So number 7, we're going to try coffee. Okay, so coffee is something that a lot of people drink every day, and we're going to look at the pH of coffee. So coffee is a dark liquid, so it might actually affect the color of the pH strip, but we're going to make our best estimate in comparison to the pH levels, even with the color on it. So here we have coffee. It looks like it didn't stain it too bad. Okay, so this is what it looks like after it's been dipped in the coffee. Is coffee a pH of 1, a pH of 2, pH of 3, pH of 4, pH of 5, 6, 7, 8, 9, 10, 11, or 12. Again, this is the color of the coffee strip. Compare it to the acidics, compared to the basics. Okay, next up we have a household cleaning product, and that is bleach. This is concentrated bleach. So let's see where it falls on the spectrum. Color of the pH strip, dipped in instantly. When you dip it in, you can watch it turning really, really dark, right? It's quite dark. And actually the bleach is actually taking the color out of the darkness. So we're actually going to compare it to the dark side first before it actually all goes away. So is it a 12? Is it can we see it? Is it a 12? Is it an 11? Is it a 10? 9? 8? 7? And by then the color is actually already faded. So we're going to try to grab another strip just to see the initial color of the bleach. So as you can see, the bleach is actually fading the color on the strip itself really fast. So in case you haven't noticed, there's a reason I'm not even comparing it to the light side, sorry, the acidic side, because it's nowhere close to red, right? When you initially dip it, it's really, really dark, and then it gets lighter really quickly as it goes on. But we're going by the initial color of the pH strip. One last time, just for quick reference. Okay, so that was bleach. And The last solution that we have that's leaking all over my counters right now is baking soda in water. Let's see if there's an easy way to move it over. You put it on top of a paper towel. So baking soda dissolved in water is our last solution that we're going to do. And when you put the strip in, it immediately turns this lime green. So is that a pH of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. Again, it's this lime greenish color. And which side does it match with? Cool. So those are our 9 solutions. And I'm going to ask that you go ahead and do your calculations following. If you need to go over, you can always go back and pause the video and write down the information. So as of now, you should have all of your solution names down. You should have your predictions down, and you should have your actual pHs down. Using your actual pH, you're going to be able to calculate the concentration of hydrogen ions, and then using your logical skills of hopping from how many times you have to hop to 7 to tell me, is it blank times as acidic or blank times as basic as water?